This is the fruit battery experiment. This experiment relates to electricity units, or to circuitry units, or even to acid and base units. This is a fairly complicated experiment, but it has a lot of good applications in the classroom. You will need some lemons. You can use any citrus fruit. You can even use apples, but lemons are large enough that you can fit the zinc and copper diodes in there easily without them touching. You will need cables. You'll need at minimum 6 cables, but you can do 8 or 10 depending how many cells you decide to use. You will need a tiny LED light bulb. So it's very key to look at the voltages of the different light bulbs. You want to stay in a fairly low range. If you're only doing 4 cells, you want to stay in the 1.8 to 2 volt range. Or if you add some more cells, you can do the 3 to 3.2 volt range, and it adds more contrast and the color is brighter. Here's what they look like close up. And you'll also need some zinc and copper. You can cut this into small pieces. This is what they'll come like. Cut them up into pieces as small as this. These will all be donated to your classroom. The important thing is to not let them touch. That's part of the other thing. So step 1 is to take your lemon, and you're gonna want to cut off the bottom parts of the lemon so that it'll sit flat. Your goal is for it to look like this and to see the top part like this. So you're gonna want to do this before your students get to class. Cut off each end. And then cut right down the middle. And there you have it, your lemon that will sit up all on its own. The next step is to place your zinc and your copper into your lemons. You should have 1 piece of zinc and 1 piece of copper in each of your lemons, but the most important thing is that your zinc and copper do not touch. So you want to keep them as far apart as possible. It's easiest to get them in if you go in one of the segments in the lemon. So just stick them in, and that's it. So I'm going to be using a 1.8 to 2 volt to start off with when I have 4 different lemons. So you just take it and you want to bend the 2 ends open. Take an alligator clip and connect to one end. Take another alligator clip, connect to the other end. And then if it doesn't turn on, you just want to flip it. And there you go, it glows. So this is fairly faint because we only have 4 lemons and we're using a fairly faint bulb, but if you add some more cells with some more lemons, you can get a higher wattage light bulb to light up, like a 3-watt purple light bulb. Provides some more contrast and it's a little easier to see. Okay, so here's the tricky part. You want to make sure that with your alligator clips, you're connecting only zinc to copper. So when you start your circuit, you should start by connecting to the copper or the zinc, whichever one's closest to the front, and then just letting it hang loose, because that eventually will be connecting to our light bulb. Then you're going to take a new alligator clip, connect it to the zinc, and then connect that zinc to the next lemon's copper. So I'll repeat that again. It's easy to know and keep track of the different cords if you alternate between 2 different colors. It just makes everything easier to see. So you're going to want to take an alligator clip, connect it to zinc, connect the zinc to copper. Then you're going to want to take a new alligator clip, connect the zinc to copper. And then take a final alligator clip and connect the zinc to your light bulb, which will go in the middle of these. The important thing is once you're finished, you should have 1 alligator clip that's loose connected to the zinc and one alligator clip that's loose connected to a copper. Okay, so I've gone ahead and I've connected 2 more halves of lemon, and so because of this, I'm going to be able to make this higher voltage, more vibrant light shine. So I'm just going to go ahead, connect either end, and because it's not working, gotta flip it around. There's really no way to see which end is which, so you just gotta flip. And there you go, you can see the purple light. So this will be a little easier for your students to see, hopefully. But it's a really cool experiment to do if you're talking about circuits or if you're talking about electricity. There's a lot of things that could go wrong in troubleshooting with your class, and asking provocative questions towards them and questioning their understanding will help them to gain a more complete understanding, and they'll be able to become experts in this experiment. And here you can see as I connect the 2 ends of the alligator clips, the light bulb lights up. That's the end of this experimental procedure. Thanks for watching.